what is it called? Like a funnel cloud type of thing. It moves in, like a tornado type of thing. So it moves inwards, and it brings along bad weather, obviously. So high pressure, once you go to low pressure, could never go in a straight direction because of the Coriolis effect. And the Coriolis effect makes things go around. So as it spins, it would always tilt to the right. So the high pressure would never have a direct contact with the low pressure unless it's closer to the ground. Then the ground friction would actually let it go in a straight direction.
Right.
So the closer we are to the surface, the straighter it will go. So, all this nonsense I just talked about, why do we need to know it as pilots?
Because we can take advantage of it.
Okay, take advantage of it, exactly. So, it would help us plan a flight, which means, how is it going to do that? All right, I want to fly from here to Pennsylvania. So I know that there's a high pressure in front of me. Which way do I go? I go above it or below it? So now I already know that the high pressure goes in a clockwise rotation. I know it's sinking air. And I know that it would always, because of the Coriolis effect, it goes to the right and sinking air. So if I'm going from the east to west, and I see that pressure system, so I know that the north of the system blows directly at me,
Yeah.
and the bottom of the system, the south of the system, blows away from me. So if I go north, I'm gonna have a great takeoff production of lift.
Yeah.
But
Sure.
that,
The rest of
that's basically the only advantage I could get out of it.
Yeah,
But otherwise, the faster it is, the slower I go, and the more difficult it will be for me to go about it. So I'm going to go underneath it. So why do I go underneath it? For a simple reason. I got the tailwind. So as I go beneath it, I got better ground speed, and I could fly faster. I save gas. I get to the destination faster than that. So always south of the eye, going west, and north of the eye, going east. The low pressure goes the other way around. It's a counterclock rotation. So I would want to be north of the low, going west, and south of the high. So I take advantage of both weather systems to get a better ground speed and better gas mileage, as they call it. You know. So how do I know which way do I go? Like how do I know how to read the map? Where's the high? Where's the low? Where's the eye going? Which way is it moving? We open the prognosis chart, the surface condition, and we see a few different marks over here. We see the low pressure, we see the high pressure, we see the through, we see the ridge, and we see the curl. Let's break them down. Okay, ridge is associated with low pressure. It's unstable. It moves around in a counterclock rotation, and I know there's going to be a lot of unstable air flying through. Then the ridge would be associated with the high pressure system. Now sometimes we could confuse it with what we didn't talk about yet, with a front. This is similar to a front, but it's not a front. This is close to the ground. This is weather that when we fly low, we feel that weather. So it's kind of different. Then we got the curl in the center of it. We see a bunch of weather systems trying to move into the center location, and this area over here basically stops it from moving anywhere. I like to call it the traffic cop. It tells everyone, hold off, stay where you are, nobody move. I'll let you know when you're clear to go. So they're kind of trying to push in, and it creates kind of a bubble that no one could move anywhere, and that brings along actually good weather, calm wind, and that's basically where the weather comes in altogether. I mean the pressure that comes in. A good place to look for that stuff is aviationweather.gov. That gives us a lot of breakdowns. So as we look over here, where the green is, we see the small lines that we see running through. They're called isobar. ISO in I forgot what language.